So one of the reasons why we started health optimization medicine in practice was to teach doctors and how to optimize health rather than treat disease, right? And one of those factors, we get the question a lot, why don't we check genetics? Why aren't we checking DNA? And, all the services out there that are checking your DNA and telling you what diet to eat or what supplements to take, but they're not checking the expression of those genes and how they're being expressed. That really matters. And that's what you can do looking at epigenetic biomarkers, looking at metabolomics. And one of the things that you and I geeked out on a lot when we first started talking was metabolomics, because metabolomics is the study of the real-time cellular processes, looking how well you're utilizing your vitamins, your minerals, your nutrients, because these are the things that become epigenetic modifiers. Welcome back to the Smarter Not Harder podcast, your home for 1 cent solutions to $64,000 questions. I'm your host. My name is Dr. Scott Sherr. Our guest on today's show is Dr. Lucia Aronica. And we've known Dr. Lucia for many years. She's a part of our health optimization medicine and practice faculty. She wrote our Epigenetics module. The essential certification for health optimization medicine includes this particular module. We had a lot of fun speaking on this podcast. And here's a quick bio for Lucia. She's a lecturer at Stanford University, an instructor of the Stanford Genomics Certificate. Her research and teaching focus on Nutrigenomics, the science of how nutrition, genetics, and epigenetics interact with each other to impact our health and longevity. Lucia has 20 years of research experience from Stanford University, the University of Oxford, University of Vienna, University Federico II of Naples, as she would say because she's Italian, and the University of Southern California. She has published research papers in top-ranked peer-reviewed journals such as JAMA, Cell, and Genes and Development. Lucia has a new free webinar that's going to be available soon, so see the links in the caption below. We had a lot of fun on this podcast, and here are a couple things that we spoke about. Well, we first defined what epigenetics actually is. We talked about common epigenetic modifications, epinutrients, endogenous bioactive compounds, the percentage of our genes contributing to obesity and diabetes, the DIETFITS study, the results. Was this really a high-carb study versus a low-carb study? Men and women in this study, the biggest losers in the study, and methylation changes, epigenetic biomarkers of glucose metabolism, genes in the response to a low-carb diet, something called the GPS score, low-carb and mental health studies that are starting just now, Nutrigenomics, including metabolomics, epigenetic clocks and the various types, and how not to use them. This was actually my favorite part of our conversation because there's a lot of interest in epigenetic clocks, and Lucia actually gives a really great perspective on how to think about these and how to use them on a real-time basis. And finally, 3 ways Lucia lives smarter, not harder. Please enjoy this episode. Without further ado, Dr. Lucia Aronica. Dr. Lucia, good to see you.
Great to see you, Scott, and thank you for having me.
It's been too long since we've seen each other, either in person or on video. So it's really great to be back with you. And so I'm going to give an introduction ahead of time, as I said, but just as a reminder, Lucia has been instrumental for the nonprofit organization, Health Optimization Medicine and Practice, that we run over here and that supports the podcast. Lucia is the primary author of our Epigenetics module. And I had the great benefit of meeting you in person at Stanford and talking about this module and creating a clinical framework on top of what you've been doing for so many years at Stanford with teaching epigenetics and epigenomics and things like that. So first of all, I just want to thank you for your contribution to our nonprofit organization. It's really, really appreciated.
Well, my pleasure. I think science and curiosity for knowledge brings together people who are like-minded and I want to make the world a better place.
Sounds corny, but I do too. I really do too. And so that's the whole idea with the podcast, with the nonprofit organization, trying to give doctors a new way to practice health rather than focused on disease. And that's really what I want to focus on today with you is your specialty, epigenetics. And you have so much knowledge and so many places where I'd love to go. And I know you specialize in the world of low carb. And I know you've been a speaker at multiple low carb Denvers. Were you there this last year as well, by the way?
No, not this last year. The past,
not this year.
The last one before the pandemic, and it was awesome.
Yeah, that's before I lived in Colorado. So this year I wasn't there, but I'd love to go some year, and hopefully we can connect there at the very least, since I don't live in California anymore. But I know you've been involved in the low carb world, and you're a big fan of that as a potential method for many people to help optimize their biomarkers, their epigenetic biomarkers that we'll talk about, their lifestyle biomarkers, et cetera. So we'll get there. But before we start on let's call it probably the fun stuff for you and I think the important thing is to kind of start off with some relative basics. We don't have to get too basic for people here because most people are going to be at least relatively knowledgeable when they first start listening to our podcast, because we get into pretty complex topics. But when we're talking about epigenetics, let's talk about, basic definition for now, and then the most common types of modifications that we see and that we're looking at when we're looking at some of these studies and some of the other things that we're going to be talking about later.
Yes. So the prefix epi means on the top. So if your genome is your DNA, then your epigenome is a set of molecules, the epigenetic marks that we will address later, that are on the top of your DNA and can turn things on and off. Just like a dimmer switch modulates lights up and down in a room. And the epigenetic modification are also heritable through cell division. This is an important property of the epigenome. So they are, on one hand, flexible enough to be modulated by the environment, lifestyle, your daily choices. But on the other hand, stable enough to persist through cell division. And the delicate balance between this flexibility and stability is crucial to a fundamental property of the epigenome, which is called epigenetic memory, the ability of the epigenome to store a memory of your lifestyle experiences, which shouldn't be confused with epigenetic transgenerational inheritance, another phenomenon that has been demonstrated in plants, animals, and for which there is some suggestive evidence in humans too, and we can talk about later. So epigenetic memory is a fundamental property of the epigenome, which is not controversial, right? And epigenetic transgenerational inheritance has not been fully demonstrated yet experimentally in humans, but there is evidence, strong evidence in animal and plants models, and probably is something that is happening also within us.
Interesting.
And so,
go ahead.
Go ahead. You were asking about the main epigenetic modifications. There are.
Yes. Yeah.
I mean, the world of epigenetics is expanding. And so we are uncovering different modalities of epigenetic regulations. But the most studied modifications by far are DNA methylation and histone modifications. So DNA methylation is the modification of cytosines of the letter C within the sequence of the DNA, and these cytosines are methylated within CG nucleotide strips, which are called CG dinucleotides or CG islands, and usually methylation is a silencing modification, DNA methylation. Not always. Right. It depends on where it takes place on a gene. Usually, if it's on the promoter of a gene, which is the master switch of a gene, DNA methylations tend to be a silencing modification. If it takes place within the gene, then it can actually turn on genes. So it's complicated, but usually it's a silencing modification. Whereas histone modifications are modification of the histone proteins that wrap the DNA inside the cell to make it compact and organized. Because our DNA is a very long molecule, is 6 feet long, and to fit inside the cell nucleus, which is 3 to 6 micron, it really needs to be coiled. like my hair, and and
Yes, you know, your
coiled
hair.
around
That's lovely.
proteins called histones. So these histones are positively charged, and the DNA is negatively charged.
Mhm,
So uh, uh, histones and DNA together form the chromatin, what chromosomes are made of. And the chromatin is the gateway of gene expression. What I mean by that is
mhm,
that whether a gene is on or off, it depends on whether the chromatin is in a closed conformation. In this conformation, the gene cannot be read, so the genes
mhm,
are off, or in an
mhm,
open conformation, and in this other configuration, the genes can be read, and the
mhm.
modifications to the DNA through DNA methylation or histone regulate the opening and closing of the chromatin. With regard to histone modifications, this regulation happens at two levels. On one hand, we have a change, so epigenetic marks can change the electrostatic interaction between
Mm,
histones and DNA. And by doing that, they can open the chromatin. On the other hand,
right.
these epigenetic modification also work as recruiters, as flags that are put
Mm,
on the histones and call or recruit histone modification machineries and chromatin remodeling machineries that then open the chromatin and close the chromatin. And here I want to introduce an analogy that I usually use in my lectures. So these chromatin remodeling machineries are, I call them like writer or eraser enzymes. So these are enzymes that can either write or erase epigenetic modifications on our genes, and they can also read them. And so read them and then either open or close the chromatin. And these writer and eraser enzymes are really a sensor of the environment, that mediates the communication between our environment and the epigenetic outputs, because their function can be modulated by various things we do or are exposed to every day, such as
mhm,
nutrients in the food we eat, chemicals. We are surrounded by additives
mhm,
in our food, lots of things, and
mhm,
even emotions. Emotions we
mm,
feel every day, or emotions, past emotions that we had when in our childhood. And so in a way, that's where sometimes you hear a lot about epigenetics, but people who are more in the spiritual world, or they talk about consciousness, and because epigenetics is also in a way a, a, a science that explains how emotions and our thoughts can be embodied in a way, can become biology, and can affect
mhm.
our genes. So it's a very interesting science that has something for everybody, I believe.
Yeah, it really does. And I love the way you've described it because it gives you a sense of just the power of understanding epigenetics and just how much is available to us now, even over the last decade or so. I mean, we were very gene centric as a community, as a population for many decades, especially with the Human Genome project that finished in the early 2000s, thinking everything was going to be solved knowing our genetic code. The problem with that, as we know now, is that how many diseases have been cured just looking at the DNA? Very, very few, because most of what's happening, as you've just eloquently described, is related to how epigenetic modifications are exerting pressure on our cells, on our body, as we embody all of these things, whether it be the food that we eat, the nutrition that we have or that we don't have, the emotions and the trauma, and how this is all being coded in various ways, or maybe coded isn't the right word, but maybe changing the expression of various proteins related to the expression of genes that maybe would not be expressed in various ways otherwise, or would be in otherwise, depending on the situation. So, so I think it's really the power. And one of the things that you sent to me earlier when we were first talking about epigenetics in the context of health optimization medicine and practice was that you thought of epigenetics as the secret agent of health optimization medicine. And I'd love to tell you've already kind of described this, but why would you classify it that way?
Yes, I'm very happy that you're bringing up this analogy. I remember, yes, I think because epigenetics can be viewed as a sort, we call it deus ex machina in Latin. You know that I'm Italian and I like this expression. But in English, you could translate it into a secret agent, which is basically what...
It sounds much better in Italian.
What is really moving, what is happening behind the scenes at the epigenetic level when we make lifestyle choices to improve our health. So all the concept of lifestyle medicine really is mediated at the biological and fundamental levels of the genes through epigenetics. And that's why sometimes I also describe nutritional epigenetics as the science of how using food as medicine for your genes. We all know in the world of functional medicine that lifestyle is medicine, food is medicine, and epigenetics mediates this. I've also... Sometimes I use describe this as a concept in my lectures, the concept of epi-wellness, which is this idea, just the epigenetic awareness of your lifestyle choices. And there is a bi-directional relationship between, I hope so, that by learning about epigenetics, you can reinforce your motivation about making good lifestyle choices. And on the other hand, by making good lifestyle choices, you are improving your epigenetics. So it's, I think, a positive feedback loop right there in this concept of looking at epigenetics as a secret agent of health optimization medicine.
Right. Yeah, I think that's beautiful. I mean, the way we always talk about this, and I know you talk about it this way as well, is that I saw something funny the other day. It's kind of politically incorrect, and it was showing a picture of New York City back in the 1920s, and it was a colored photo, and everybody is skinny, and the basic premise is, where were all the fat genes then? And I laughed out loud because there's been a lot of emphasis, and this is something we can talk about, right? That that it's my genetics that make me obese, and it's my genetics that make me fill in the blank. But we know that, and you could give me percentages here more than I can, but the amount of contribution from our DNA versus our epigenetics, what would you say as far as the breakdown there for people, just to give them a sense of, listening to people on TV and saying, well, it's my genetics because I'm obese, or it's my genetics because, we certainly know there's genetic predispositions for things on your DNA. There's no doubt about it. We have people that live over 100. Those people have certain genetic signatures that we're still trying to figure out. But what would you say to something like that, as just a curiosity?
Oh, yes. So although hundreds of obesity predisposing genes have been identified, it is estimated that collectively those genes explain less than 3% of the variance in BMI and body mass index among people. And
3%. Wow.
3%.
Yeah.
And, with diabetes, the type 2 diabetes, it is estimated that 30% is genes. But honestly, I think these estimations are probably very generous. with type 2 diabetes. Of course, type 1 is another.
It's different.
Is different.
Yeah.
But the point I want to make is that, yes, there are some very rare genetic variants that are called fully penetrant. Sometimes they're also called mutations. So mutations are genetic variants that are very rare, less than 1% in the population, and sometimes 1 in millions and even more. There are some obesity associated mutations. So if you have, for example, in the leptin gene, this is a famous one. So when you have that mutation, yes, children are obese, they overeat, and by giving them leptin, actually, this is a therapy, right? But these are very rare conditions. We are talking here, what you and I are talking about are these common variants that presumably predispose people to gain weight or not. And many of these variants are included in genetic interpretation profiles. Now getting a personal genetic test is very common. And then, for example, FTO is a very famous gene associated with gaining weight, with fat, saturated fat. And the reality is that if you focus on what count most, which is epigenetics, if you focus on what makes the 80% of a result, and this is the Pareto principle, right?
Yes, we know this well. Yes.
Yeah, then you're fine independently on your genetics, and there are numerous studies showing this. Even so, for example, we know that people who have a high polygenic risk, which is many genes contributing to cardiovascular disease, if they adopt a favorable lifestyle with diet, including diet, exercise, and stress reduction, actually the difference between them and those who are blessed with a low risk for cardiovascular disease is cancelled. Basically, we are saying that lifestyle really can cancel out and override the effect of common genetic variants. And this is powerful. And I see even, I have friends and families that still blame their genes or some of their predispositions. But the reality is that lifestyle is just the most important thing. Myself, I have a predisposition to be diabetic and have high blood pressure and low HDL. So since I actually went on a high fat, low carb diet, my HDL is so high. I can pick my blood report among hundreds because I have very low triglycerides because I don't eat. And my HDL is 135 milligram per deciliter. And my triglycerides are in between 30 and 40s. And
your HDL is 135?
135. And
that's high. Yeah.
And I've been my 23andMe report using the so far most accurate method available, which are these polygenic risk scores. We can talk about later, but basically they are capturing the collective impact of many genetic variants in one number. So by using this very accurate method, I've been told I'm predisposed to have a low HDL, and every time I go to the doctor and the doctor says, "What is this?" You are genetically predisposed to have a high HDL. They think it's the opposite. It's always the gene. They don't believe that the lifestyle can do magic. But
it's amazing. I mean, so one of the reasons why we started health optimization medicine in practice was to teach doctors and really how to optimize health rather than treat disease, right? And one of those factors, we get the question a lot: why don't we check genetics? Why aren't we checking DNA? And all the services out there that are checking your DNA and telling you what diet to eat or what supplements to take, but they're not checking the expression of those genes and how they're being expressed. That really matters, and that's what you can do looking at epigenetic biomarkers, looking at metabolomics. And one of the things that you and I geeked out on a lot when we first started talking was metabolomics, because metabolomics is the study of the real-time cellular processes, looking how well you're utilizing your vitamins, your minerals, your nutrients, because these are the things that become epigenetic modifiers, right? These are the things that become I think you describe them as epinutrients. Is that what you call them? Is that right?
Yes. So the conversation there is more nuanced. Yes, epinutrients are nutrients in the food we eat that
Okay,
can
yes.
that modify our epigenetics. So they're really the epigenetic power molecules in the food we eat. But as you were mentioning, there are also metabolic cofactors
Right.
in that we produce in our body, and these sometimes are even driven not so much but by the micronutrient composition of our food. So the epinutrients are usually, we are talking about micronutrients in the food we eat, but by the macronutrient composition. For example, an extreme example would be a keto diet where you restrict carbohydrates. You are just manipulating, we're talking about manipulating the macronutrient composition, and by doing so, inducing your body to switch from using carbohydrates as a fuel to using fat as a fuel and producing ketones. Now, ketones are epigenetic modulators, are actually modulating the activity or some eraser enzyme. We were talking about erasers.
They're HDACs, yes?
Yes. These are histone, they acetylase, so they erase acetyl molecules from our histone. So that again, epigenetic and food can modify our epigenome through epinutrients, but also by inducing the production in our body of endogenous molecules and metabolic cofactor that also modulates. So food is so powerful. It's just such a playful tool to really play with the Play-Doh of our epigenetics and be the creator of our best self. Let's do it.
Yeah, I love the Play-Doh analogy. That's a good one because they can be really molded depending on our diet, our lifestyle, our circadian rhythms. All these things really fall into the category of things that we can mold and optimize our epigenetics. One thing on the ketone side of things, so it's beta hydroxybutyrate that is the HDAC as well, right?
Yes.
Yeah. So on that train, I wanted to talk about where a lot of your research started, which was the DIETFITS study over at Stanford, right? So I wanted to talk a little bit about that study, and for those who haven't heard about it before, what your involvement was, and then from there we'll kind of dive into, because I think what's more interesting about even the study is some of the subgroups and looking at the epigenetic modify or the biomarkers in various groups to see which categories of people really would benefit and how you're kind of trying to figure that out. So maybe start with like the DIETFITS study and kind of we can run down from there.
Yes, the Stanford DIETFITS study is the reason why I moved to Stanford, because it is the follow-up of a previous study called the A to Z study, which I read when I was doing at that time my PhD in Vienna. And the A to Z study was testing the effects of 4 diets from Atkins to Zone, different carbohydrate composition on weight loss and blood lipids. And basically it showed that the Atkins diet, so the lowest carbohydrate diet of the 4 tested, was inducing the greatest weight loss and lipid benefits. And this is what I was experiencing at that time when I first tried a low-carb diet. So I decided then to join Stanford because the DIETFITS study is the larger version of the A to Z study, the larger randomized clinical trial ever undertaken to compare a low carb and low fat diet in 609 men and women, overweight or obese, who were randomized for 1 year to either a low carb or a low fat diet. Now, the beauty of the study, as you mentioned, is that this is also the largest randomized clinical trial ever undertaken in the field of personalized nutrition, because we were collecting lots of data, genetics and I still didn't work on that. I didn't finish working on that. I've still some analysis in the pipeline. So genetics, epigenetics, microbiomics. Other people were working on the microbiomics. Also, the microbiome paper is not out yet. So
I was going to ask. Okay.
What I wanted to illustrate is that this is a huge data sets. And another analysis that I'm facilitating is the analysis of bilirubin in people as a biomarker potentially of a low carb, a low fat predisposition. Anyway, more to come.
Interesting.
This is a collaboration
Well, I want to know more.
The University of Vienna. I'm just saying that there are many things happening still with that data set. So although the study was ended in 2018 and the main publication of the weight loss data was published in 2019, we still are analyzing the data sets. So my first analysis... Yeah, go ahead.
No, I was just going to say, I think that's really interesting background. I mean, I can't imagine how much data you guys collected and how much is still to be figured out. But I think I love that you're trying to figure out, and this is what I'm interested in talking to you about in a minute, but you're trying to figure out what these biomarkers are that you can look at, say, this is the population of people that would really benefit from being on a low carb diet. This is the population that maybe wouldn't benefit, because we'll talk about the results of the study at least, and then maybe some of the challenges of interpretation of those results as well.
Yes. So just to go straight to your question, and the main study didn't show any difference in weight loss between people who followed a low carb or a low fat diet. But then now we are nailing down and looking at different subgroups of people with different epigenetic marks, people with different microbiomic signatures, and so on. So the first publication that I was leading for this study was, I was looking at men and women. And we found out that actually the men lost more weight and body fat on the low carb diet compared to the low fat diet. And and we're also following the diet more with a greater adherence. So they were more compliant, where they were eating more fat and less carbohydrates compared to the women. The women lost the same amount of weight on a low carb and a low fat diet, despite not following the low carb diet as well as the low fat diet. So basically they were not cutting carbohydrate enough and they were not eating enough fat. So basically compliance being equal, everyone was losing more weight and more fat on the low carb diet. If we were focusing on, so if you look at this
of adherence, right?
Yeah. So this was just, it was not a molecular analysis. It was really looking at people, different people, even just the most obvious difference that we have, men and women, and behavior. And I think this is important because unfortunately the low fat industry is targeting mainly women. So every low fat yogurt at the supermarket is pink. We know that.
Oh yes, of course. Yes, yeah.
So it's not a surprise that people, women,
they don't make pink barbecue grills, do they?
Yeah, and of course, this is, if you don't increase your fat intake, then you are not able to stick to the diet and enjoy it. So there are some considerations to make there. And then another analysis I conducted 2 analyses on the epigenetics that we didn't publish yet. I can already reveal something because, until we publish the data, there are so many angles that we can look at. And I would love to have some collaborators on this, because these data sets, at Stanford, we have the luxury of having too many projects to work on. And so some projects, get deprioritized. But basically, we have a genome-wide. We looked in the first analysis. I looked at the whole methylome, DNA methylome changes in people in the biggest losers of the study, the one who lost.
So the methylome would be the methyl. So we're talking about methyl groups. We're talking about modifications.
Yes, DNA. So I was looking at DNA methylation because DNA methylation is the epigenetic modification we can most reliably and accurately measure. So focusing on that, I was looking at the DNA methylome of the biggest losers of the study, the one who lost the greatest amount of weight, and on a low-fat and low-carb diet, men and women. And it was incredible to see that there was a very little overlap in terms of DNA methylation changes between the diets. So basically, a very, the weight loss driven by two distinct diet drives very different changes in the DNA methylome. I mean, this is just by itself.
That's pretty amazing.
Very interesting.
Yeah.
And
so it's not an end process. It's something happening very separately to cause the weight loss in these two different populations.
And then we just looked at the top. The top 10, top 20 regions that changed the DNA methylation before and after the diet. And we found interesting things and confirmation, like on a low-carb diet, there were changes. The greatest changes were in genes responsible for fat metabolism, right? So basically, you are starting to burn more fat and use the fat in the food you eat. In the low-carb, in the low-fat diet, there were also interesting changes in genes involved in the protection to colon cancer. So again, the analysis is not done yet. We could do so much more. It depends on what the questions that we ask. But basically, what I can tell you is that there was very little overlap, and the changes were huge. I'm talking about like 10 to 40% change in DNA methylation sites, whereas the studies conducted before our study were showing on average a 5% change. So I'm talking about huge changes, probably because we were focusing on the biggest losers there. And then the other analysis that touches more on the topic of personalized nutrition and biomarkers, as you mentioned. We looked at a specific epigenetic biomarker of diabetes, and is within a gene, as a DNA methylation modification within a gene called ABCG1, which is a diabetes-related gene, and that gets more methylated, so turned off as people gain weight. And is it believed that this process of gaining weight then turns off this gene, and then this in turn contributes to impair glucose control. And so it's a biomarker of beginning glucose control abnormalities before they actually happen. And we look at that, and we see that a reduction of the methylation at that sites on both diets. Again, we didn't end that analysis for various reasons, also connected to my personal stories, that at that time then I had to go back to the European Union to start this bilirubin collaboration, and then when I came back I had other projects waiting for me, but
of course
I will get there. And also let's remember I'm teaching also, and I was involved with your great program. Yes, so I have only one life and many things I love doing, but I will get to that publication. But the good news is that basically we have a epigenetic biomarkers of diabetes, and losing weight on a whole food diet is good for you, because both diet, the low carb and low fat, were anyway healthy. So based on health or whole foods, and therefore they were both low carbohydrate compared to the standard American diet. This is a point I want to make. So
Please.
yeah, so it just,
so you're referring to the study itself, right? As far as the two groups,
and,
yeah. So talk about that for a minute.
And also in general, you asked me about, we can generalize this from the study to everyone who is listening, because I'm asked this question over and over: what is the best diet, right? And then personalization. So I think 80% of the equation of a healthy diet is focusing on whole food, whole non-processed food. By doing so, you will hit a lot of things that we all agree on: having more nutrient dense food, because processed food, also lowering carbohydrates. So it's not controversial that we should lower our intake of refined carbohydrates and sugar. I think.
Do you have some numbers that you know of already, Lucia, compared to what was in the DIETFITS study compared to like the average American? What was the difference there? Or typically,
the difference there was that people were encouraged to get their carbohydrates mainly from fruits, legumes, grains, not whole grain products, because it's also different. Whole grain bread, no, actually the whole grains, which is still it's still a low carbohydrate diet. Who is doing this diet? I think this would be considered a low carb diet by most people, and it was in a way.
Right.
But then
so their high carb diet was really like a low carb whole food diet, is really what you mean, compared to the average American.
Yeah, right. The average American, unfortunately, gets most of their carbohydrates from refined carbohydrates and sugar.
Right.
That's the way it is. Yeah. So I think really the message there is, okay, universally and not controversial, let's stick to whole food. And you will get anyway a reduction in carbohydrates for sure, and an increase intake in micronutrients and epinutrients, what I care most about. And you will also stimulate the production in your body of these metabolic cofactor and endogenous epigenetic modulators that we were touching on before. And so this is the universal part. Then there is a 20% of personalization. So how low with carbohydrates should you go? Is dairy good for you? Is should you how much green leafy vegetables should you be eating? Do you require more? Can you use plant-based omega-3s, or should you rely only on marine-based omega-3s? So these are the nuances. That's where I also think, and that's where Nutrigenetic can help.
So talk about the science of nutrigenetics a little bit and how you think about that.
There are, for example, these things I mentioned about personalization. Okay, there are two factors. There is how low with carbohydrates should you go depends not so much on genetics. I think is on your metabolic state and your mental state. For example, we know that a ketogenic diet is a very effective approach for type 2 diabetes and metabolic disturbances, and but also for mental health. I'm now part of a network of researcher clinicians. It's called the Metabolic Mind. I encourage you to check it out. And it's an inspiring community who is promoting the idea that food can be medicine, not only for the body, but also for the brain. And there is an intimate connection between metabolic health and brain health. And it's not only about keto. I think it's about finding the degree of carbohydrate restriction that can help you improve your metabolic health and brain health. So this is a level of personalization, right? We are talking about
Yeah.
looking at your metabolomics and your and assess your metabolic status based on blood lipids and other things, and then we personalize. So this is the first level of personalization. Then there is the nutrigenetic part that can also help refine. So independently of where you are on your metabolic health journey, you carry some genetic variants that may predispose you, for example, to activate less folate from the folate you eat from the green leafy vegetables. So you need more of to eat more green leafy vegetables. For example, this is the very well-known MTHFR variant.
Right.
There are
This is what we can measure using metabolomics, for example, right? We can measure these kinds of gene expression challenges, like the MTHFR gene is a very common genetic heterogeneity. I don't even like calling it mutation because it's so common in the population. But certain people have various abilities to methylate their folate, like you said. But you can measure this, so you don't have to know. The gene is not as helpful as actually measuring it.
Yes, I agree with you. And actually, even if you have the genetic information, you could have both, right?
Right.
Even if you have the genetic modification, I would not modify your diet just based on that, because then it depends on your actual folate status that you measure by what you call metabolomics, your homocysteine level, because then folate is also affecting your homocysteine. So, and then actually you use those clinical markers as a response biomarker of how well you respond to modifying your diet by taking a B vitamin complex supplement or eating more leafy greens. So the clinical biomarkers, you are absolutely right, are crucial and are always, you always need to measure them. If you, nutrigenetics is only another piece of the puzzle. It can also be nice to see where nutrigenetics really describe your genetic predispositions, and the metabolomics is what you actually are doing with your.
So what's happening right now? Yeah.
So it was happening right now. So I think it's nice to have both. But other things that nutrigenetics can help with. For example, I was talking about omega-3 and omega-6s. This is also a controversial topic. Are, for example, omega-6s in vegetable oils bad for you or not? It turns out that, there are some genetic polymorphisms who predispose some people to produce more inflammatory molecules when they eat those vegetable oils higher in omega-6s, right? Anyway, we know that eating too much of those is not good for you anyway. Also because they are contained in processed food. So if you avoid them is best. But it's interesting to see how, there are some people who are predisposed to have more inflammation, and this is a polymorphism in the omega-3 and omega-6 pathway in our body that basically helps us use external sources of, for example, plant-based omega-3s to transform them in the biologically active EPA and DHA, which are those we can get from fish. Or marine sources supplements, right? And this pathway, variation in this pathway cannot not only tell you whether you are actually able to effectively use the plant-based to produce the DHA and the EPA. Most people aren't. And even those who are blessed with good genetics have 8% conversion average. 8%.
Wow.
It's very.
What is it for the animal? What is it? Do you know? Have a comparison?
No, I mean, if it's the animal is already active. So
okay, that's what I was going to say.
Basically, we are going. Our body can produce. So these omega-3s are, same is conditionally essential nutrients, which means we can synthesize them from plant-based, but this conversion rate goes down with age. is on average 8%. I think that men convert less. But anyways, even is a modest conversion rate for everybody. And so, and
Right.
then
Very smart.
genetics can make things worse. Again, here you may just say it's better to get animal-based or omega-3s for
Right.
everybody.
I mean,
But you may
we
have,
talk about this a lot.
yeah, but you may have an additional reason for, there are so many
Right.
things that where genetics is almost more, it can be used as a behavioral tool. I see this also with smoking.
True.
There are some people who are just predisposed to, unfortunately, that enzymes in the detox pathway have just experience more harm from smoking and environmental toxicants. And again, this is bad for everybody. But look, if
But
you
some people
know
have a
that you
higher
are
risk.
vulnerable, it may help you make a decision.
Yeah. I think that's well said. I mean, we talk about this, and I talk about this in my personal practice when I speak to people that do not eat animal protein, for example. I often find they're nutrient deficient a lot of times. They may do okay initially, but it's really hard because of the bioavailability of things like omega-3s and other things like the bioavailable B vitamins, for example, that you don't get that are already methylated for you from the animals, for example, rather than your body having to activate them in your system. So it's possible to be healthy that way, to not eat meat, but it's very, very difficult, is what I often tell people. And as you said, like there's also these genetic predispositions that may not be an issue, but if you're eating lots of processed food with omega-6 and you have a predisposition, it's like kerosene on the fire kind of thing, and so it's not a good scene at all. So this is really where it really becomes important, and you alluded to this, and where we are really big proponents as well is you need to test, you need to see what's going on underneath the hood for people, and look at metabolomics, look at nutrigenomics, and understand. And then the other piece, which I just want to go back to for a second, which I find so exciting, because I know I think Dom D'Agostino is part of this work with the mental health collaboration as well, if I'm not mistaken. Yeah.
Yes, he's also part. He's a huge community. He's also part of.
Yeah, you guys have such a big community, and I know that the Metabolic Health Summit has its own podcast now, and they've been doing. I think, have you been on there yet? Or I think you have been. Yes, or you're going to be. Or
yes.
Yeah. So I'm excited for that. I'm excited for Dom, who is on this show too, because I think, from like the mental health perspective, we forget that the brain is attached to the body, and everything that's happening in the body is also going to be affected in the brain. And one thing I've heard you talk about, and I don't know if this is pertinent or not, but you talked about something called a GPS score, like basically somebody's response to a low carbohydrate diet. Can you touch upon that for a minute?
Yes, the GPS score is another name of the polygenic score. It stands for genome-wide polygenic score, and basically a GPS score is a way of capturing with one number the collective impacts of many genes on a given trait or response to diet in our case. And it's the most accurate genetic tool so far to predict complex trait or response to diet. And so we are looking at ways of looking at more genes, because in the first publication of the study, we looked at 3 genetic variants that are very often reported on this genetic interpretation tool to predispose you to do better on a low carb or a low fat diet. The result, it didn't matter. Those genetic diets were not doing anything. So we want now to give a second chance to Nutrigenetics and see and look at whether coming up with a GPS score, so aggregating together hundreds or more of those variants can change things. Again, I think this will be in a clinical practice. If we find something and you decide to use this GPS in your practice, this will be one little element.
Right, it's one tool. Right.
Make the decision, because of course metabolic status, I think, is going to be more important for clinicians to to guide people toward a diet or another one. So of course, if you are,
Yeah.
for example, if you are already, you have poor glucose management control, independently if you are blessed with a GPS that
Right.
predispose you to do well on a high carb diet, I think you shouldn't do that, right?
Right.
So
Right. Yeah. The key as a clinician always is look at the patient in front of you, right?
yes.
And treat them, and don't treat the score or
Yeah.
the numbers. And I think that we get lost in the data these days because we have so much more of it. But I think the GPS score sounds like another tool in the toolbox that will help potentially work with you can work with your patients in a way that will allow them more data and more evidence that they need to make certain changes in their lifestyle and their diet and take various supplements or whatever. And I think the other one that I wanted to chat about, because I know we're kind of running out of time, this is important to me, and I think people listening, is you talked about smoking, right? And we talked about that being a big issue, and some people are more sensitive to the toxins in smoking. And what this kind of comes into my mind, what comes into my mind from here is there's been a big focus on epigenetic clocks and how these can help predict biologic versus chronologic age, or the difference between the two. And also the Grim age clock, which hasn't been commercialized yet, but the idea that you can predict your first heart attack, your first grim aged type of thing, basically when something's going to go south. I wanted to get your sense of kind of where things are in that world these days, Lucia, and like where people should be thinking about using this in their clinical practice, or if they're a patient, when they should be talking to their practitioner about maybe getting one of these tests done.
Yes, we have only less than 10 minutes, so this is a very complex topic. I'm going actually to give a talk about this there is a Stanford event on longevity soon.
Oh, good.
Yes, it will be a fun one.
Well, we'll link to it here.
Yeah,
so we can make sure we have the longer form.
Yeah. And in a nutshell, okay, what is chronological age and biological age? Perhaps your listeners are familiar with that, but chronological age is what we celebrate on our birthday, and biological age is a construct. We don't know, we don't have a definition of it. Is the physiological age, molecular age, and of your tissues and cells, and it's not one thing. Depending on which tool you use to measure it, you have a different readout. And so if we would identify all the tools possible and create a composite score, that will be probably an estimate of your biological age. But the idea of the biological age is that your true age of your cells and tissues. And just know that there are lots of ways currently to estimate it, and probably we'll have more later. Usually the way of estimating biological age is can be through functional biomarkers. So what you collect in your practice, even blood lipids, inflammatory markers, metabolomics, these are functional clocks, right? And then there are digital clocks, even like if you take a picture of yourself. We are very good at face recognition, right? You can estimate do you look younger or older than who you are? And this is could be a digital clock, right? Is the biological clock age versus the chronological age. And finally, we have these molecular clocks. Epigenetic clocks are one of these molecular clocks. And epigenetic, because epigenetic can capture our lifestyle information, and because it changes with time, we didn't touch on that, but there are some age-associated epigenetic changes.
Right.
Then,
like more methylation, for example.
Yeah.
Right.
Yeah. There are things that go up and down with age. Then we can use epigenetic clocks, which are basically capture the methylation changes at hundreds or thousands of CpG on your epigenome. We can use them to estimate the passing of time, biological time. Is your inner clock ticking faster or slower than your watch. And so now you mentioned one of these clocks. There are different epigenetic clocks. Some of them are more accurate at predicting chronological age, and this could be used. Are really like the correlation is very close. And for example, the first generation Horvath clock, this could be, for example, applied for forensic purposes. If you have a sample, you can say, okay, this was a man of 30 years old, right? Mm-hmm. But some other clocks seem to reflect more biological age, and these are especially the second generation clocks that are derived. They were developed by looking at functional changes, blood lipids and the proteins in your blood, and then looking at the correlation between these and epigenetics and focusing on those epigenetic changes. What I want to stress in this little complicated explanation is that basically they are capturing more functional changes. They are designed. The algorithm is developed to capture functional changes in your body. And the Grim age clock that you mentioned is one of these. And as you mentioned, can really estimate even time to death. We at the beginning, before the pandemic, we wanted actually to look at the Grim age clock in our DIETFITS study, and we may do that. I mean, if Steve Horvath is listening to this, I hope he remembers of this initial collaboration. We are still interested. In the meantime, there are other clocks coming up. There is also a recent clock, Dunedin pace of age, which is actually measuring the pace of aging, and it might be a better tool for estimating biological age in younger people.
Makes sense.
And
in younger,
also in the context of lifestyle changes. But I just want to just give tell people to be cautious, right? I love science and everything, but we still don't have a clear clarity on the clinical utility or even personal utility of these clocks. For example, we know that people who exercise a lot tend to be biologically older. And we don't know, this doesn't necessarily mean that these people are going to live not as long as other people, or that they look older. But this might reflect a transient epigenetic response of inflammation. You know, for example, the inflammation is necessary to mediate some of the benefits of exercise, right? But it might give you an aging signal that is going there. It doesn't clinically mean anything, right? Or so on one end, we have this very healthy, functionally healthy people who are epigenetically older. And on the other hand, we also need to understand that there are some dietary modifications, right? For example, fasting, or even a plant-based diet, that have been associated with a slowing of the epigenetic clock, because they are these interventions, either through calorie restriction or through restriction of animal-based food, they are going to regulate the mTOR pathway, which is basically a gatekeeper of the cell that tells you whether you are going to anabolism or catabolism. Are you building or destroying? Usually you start destroying and you are entering a stress resilient
catabolic state.
Yeah. But what I want to say, and this can be good for many people for obvious reasons, because we know most people are overweight and have a metabolic issue, and I think they can benefit from it. So in that case, they go on a fasting diet, they lose weight, and their epigenetic clock will also show accordingly a younger age. But
Right.
there are some people, for example, and I always talk about my mother because she's close to me. She's 82. She's frail, right? She's frail. If she starts like going on a vegan diet or the fasting, anyway, she may become epigenetically younger, but worsen her frailty,
Sarcopenia.
and then tomorrow she falls and she dies earlier. Well, the point
Right.
is, it's really practical. I want just to say,
no, this is perfect.
And,
yes,
because the people don't really grasp these little nuances.
These are nuances.
I love epigenetics, and I love epigenetic clocks, and I'm working on them, and I want the field to advance, but still
everything in context, though, right? That's what you mean.
Yes,
I think that you have to look at. I mean, I 100% agree that if you're already frail and you go fasting and you're going to get sarcopenic and lose muscle mass, it's not a good idea.
And you don't care if you're epigenetically younger, right?
Yeah, exactly. I'm 40 years old, but I broke my hip because I don't have any muscle anymore. My bones don't actually mineralize. It's so interesting because everybody wants to have that, that one thing that's going to flip them over and say, okay, I'm epigenetically 10 years younger. And that means everything else is going to be fine, right? But no, it's so much more nuanced than that. I really appreciate your nuanced conversation about this, Lucia, because I use epigenetic clocks in my practice, but I use them in a nuanced way for these particular reasons. It depends on what their goals are. It depends on how old they are. It depends on what other medical problems that they have. Because yes, maybe going plant-based or doing fasting is a really good idea for them. But that's probably more related to their metabolic health anyway than it is their epigenetic health, epigenetic biologic age versus their chronologic age, for example. So I know that there's a lot more we could talk about here on this, but I think it's funny. I was talking to Dr. Ted about this the other day. We keep waiting for the grim age to get commercialized, but I don't think anybody wants to be the company that tells you when you're going to die, do they?
That's true. Although again, I think there is room for those.
Yes, exactly.
I think
it's the same thing, right?
Yeah, I have a positive and proactive attitude to my health and life. And I think that's our mission, to communicate this to people. And so I'm very grateful for I'm very thankful for this invitation. I love hanging out with people. I invite people also to follow me on social media, Instagram. I'm also thinking of launching, actually I'm doing it now that I'm committing, in May, I think a free webinar called Ask Dr. Lucia Aronica. You can sign up at diararonica.podia.com. And I would love to see you there. Just ask me anything about epigenetics, longevity, and you will find there also a mini course.
And strength training. Come on. You can talk. I know
Not
you're a big strength trainer.
Although, yes, I finally launched a mini course. It's a smaller version. It's not the same that I'm offering with you guys. It's a smaller version of a professional course for epigenetics from showing updated content from my Stanford Genomics Certificate course. And this is just for professionals, not targeted to clinicians and any professionals. Awesome. And just I want to make top class education available to everybody and without breaking the bank.
Yeah, that's beautiful. Okay, Lucia, I have one more question for you. You can make it quick. I know you have to go, but what we like to ask everybody at the end of the podcast is, what are the 3 recommendations you have for somebody to live smarter, not harder? And this could be in the worlds of epigenetics, in the worlds of emotional health. It could be going to Mexico and spending time with your family, whatever you want to do here. But that's where Lucia is at the moment, by the way. So she's on vacation. She just spent some time with us, which we're really appreciative of. But yeah, so 3 things that, maybe 3 takeaways for people that are listening from your own personal life or professional, whichever you choose.
Yes, I think I will start with food and exercise. So find pleasure. So rediscover and redefine what pleasure is. The key to sticking to a plan, food plan and exercise is finding pleasure in it. We all follow pleasure. So if you rediscover, for example, what healthy food tastes like, and how you develop good addiction, how great it feels to exercise. At the beginning, it might be difficult to start a new habit, but then when you really focus on not I need to do that. No, I want look at a new diet or a new exercise plan with curiosity and look for pleasure. And this will stick. And so this is my foundation. Pleasure every day through food and exercise and things that make my body happy. And then I have connection, human connections. I have a strong relationship with my family, my mother, my sisters, and I think those are really my anchor point. And then from that anchor point, the third element is to just using that anchor with, imagine a balloon is attached to an anchor that can fly everywhere. And so seek new experiences. Be open, continuous learning. I look at me, I'm a mix of, I'm very independent and I go everywhere. I have a life. I've lived in so many countries and still I'm anchored. And I think a mix of, I think these are my three elements. So lifestyle and beauty, and then an anchor, attachment, and human relationships, but also fly and explore and always seek new experiences. I think these are my three.
Always curious. I could tell, Lucia, you're always looking, and it's a beautiful thing. And I just want to thank you so much again for spending more time than you planned with me today to talk about this. And we'll definitely link to your website, draronica.com. You have your Instagram as well, and your new courses. And please follow her and check out what she's doing, and always up to more things than she can chew at the same time. But I'm always excited to talk to you. I can't wait to one day be in person again in some similar location. But again, thanks so much for being with us today.
Thank you. Thank you for having me.
This has been another episode of the Smarter Not Harder podcast. Thanks so much for listening, and we hope you enjoyed the show. If you did, please head over to Apple Podcasts, Spotify, or wherever you listen to your shows and leave us a 5-star review. This would be super helpful. And while you're at it, go to YouTube and click subscribe. We had a great time, Lucia and I, speaking. I really hope you got some really interesting information from here that you can take home and start using in real time in your own lives. Thanks again for tuning into the Smarter Not Harder podcast, your home for 1 cent solutions to $64,000 questions. See you next time.